Behind every wireless connection, behind every router, every streaming video, and game download, there's a physical cable doing the real work. Today, we're diving into the complete world of Ethernet cabling. We'll break down what Ethernet is, how cables are wired, what makes some faster than others, and even when to use copper versus fiber. This is the ultimate guide to Ethernet cabling, made simple and visual. Let's go. What is Ethernet? At its core, Ethernet is a technology, a set of rules for how devices communicate on a local area network, or LAN. Imagine Ethernet like a language computer used to talk to each other when they're connected by physical cables. It's not just the cable, it's how data is formatted, transmitted, and received between devices like computers, switches, routers, game consoles, and smart TVs. It was invented in the 1970s and over time it's evolved into the standard wire networking system used around the world. Today, Ethernet powers offices, homes, data centers, and even industrial systems thanks to its speeds, reliability, and simplicity. Why do we even need network protocols and standards like Ethernet? Think about this. If every device had its own way of sending data, nothing would work together. Your printer might not understand your computer. Your laptop might not talk to your router. That's where protocols come in. They are the rules that ensure devices speak the same language, understand each other's timing, know when to send or wait, and can identify where data should go. And standards like IEEE 802.3 Ethernet ensure that millions of devices from different brands can all work together smoothly. Without these standards, the internet would be total chaos. How fast is Ethernet? Ethernet has come a long way since it started. Here's a quick speed timeline. Today, 1 gigabits per second gigabit Ethernet is common in homes and offices. 10 gigabits per second is becoming more accessible for power users, gamers, and businesses. To give you an idea, at 1 gigabits per second, you can theoretically download a full HD movie around 4 gigabytes in about 30 seconds. What is a bit? Let's zoom in even more to the smallest unit of digital data. A bit is short for binary digit and it can only have two values, 0 or 1. That's it, just on or off, like a light switch. Everything in computing, images, music, games, is made from billions of bits combined in smart ways. What is a byte? A byte is a group of 8 bits. Why 8? Because 8 bits can represent 256 different values, which is enough to represent a single letter, like A or B, a small color value in an image, a tiny chunk of a file. Let's scale it up. So, when your network speed is 1 gigabits per second, that means 1 billion bits per second, or about 125 megabytes per second in real world data. Here's something important that trips up a lot of people. Network speed is measured in bits per second, not bytes. So, when you hear 100 megabits per second or 1 gigabits per second, that's in bits, not bytes. But here's the twist. Most files on your computer, like photos, videos, or games, are measured in bytes. To learn more about binary language, watch the video above. What is UTP cables? UTP stands for Unshielded Twisted Pair. It's the most common type of Ethernet cabling found in nearly every home, office, and classroom. Inside a UTP cable, you'll find four pairs of wires twisted together. Each wire is color-coded, like blue, orange, green, and brown, and one each pair has white stripes. Why are they twisted? Because it reduces electrical interference. When signals travel next to each other, twisting helps them cancel out the noise. There's also a category system. The higher the cat number, the more bandwidth and speed the cable can handle. Cat 5e support up to 1 gigabits per second, most common today. Cat 6 up to 10 gigabits per second, but only for about 55 meters. Cat 6a, Cat 7, and Cat 8 better shielding, longer 10 gigabits per second support. These copper cables are flexible, cheap, and easy to install, perfect for short distance networking. When we talk about Ethernet, we're really referring to a family of standards under the IEEE 802.3 specification. These standards define how fast Ethernet can go, what type of cabling it uses, and how it transmits data. The base T means baseband over twisted pair, and the number at the beginning tells you the speed 10, 100, 1000 megabits per second or 10 gigabits per second. These standards ensure that devices from different manufacturers can communicate as long as they're following the same IEEE rulebooks. Now, let's talk about pinouts. How each wire inside the cable connects to each pin on the RJ45 connector. Numbered from left to right when you're looking at the plug with the clip on the back. RJ45 connectors have 8 pins. Numbered from left to right when you're looking at the plug with the clip on the back. Two standard configurations, T568A, T568B. The only difference is how the green and orange pairs are arranged. 10 100 megabits per second Ethernet only use pin 1, 2, 3, and 6. That's two wire pairs. Gigabits Ethernet 1000 base T use all four pairs, so every wire matters. Pick one and stick with it for your whole network to avoid confusion. A straight-through cable connects different devices. Think PC to switch, switch to router. Why? Because these devices send and receive on opposite pins. No need to cross anything. Let's break down what's really happening when you plug a PC into a network switch using an Ethernet cable, specifically a fast Ethernet connection, also known as 100 base T. Here's the connector we're using. It's called an RJ45. It has 8 pins, numbered 1 through 8. But here's the first surprise. Even though there are 8 pins in total, a 100 base T fast Ethernet connection only uses 4 of them, 2 twisted pairs. Let's say we're connecting a PC to a switch using this fast Ethernet connection. The first pair of wires is at pins 1 and 2. On the PC, pins 1 and 2 are used to transmit data. We'll call that TX. On the switch, pins 1 and 2 are set to receive, or RX. PCs and servers transmit on pins 1 and 2, switches receive on pins 1 and 2. Now, we need to go the other way, from the switch back to the PC. That's where the second pair comes in. And no, it's not pins 3 and 4. It's actually pins 3 and 6. On the switch, pins 3 and 6 are used to transmit TX. On the PC, pins 3 and 6 are set to receive RX. This setup creates what's called full-duplex communication. Full-duplex means both devices can send and receive data at the same time without any collisions. It's like having two one-way streets, on going into the city and on going out. No crashes. Each device has dedicated wires for sending and receiving. That's what makes fast Ethernet so reliable. But when you're connecting similar devices like PC to PC or switch to switch, you need a crossover cable to reverse the transmit and receive pins, so data doesn't just crash into itself. Now, what if you connect two similar devices? Let's say you connect PC to PC, router to router, switch to switch. Here's the problem. Both devices try to send data on pins 1 and 2. Both devices listen for data on pins 3 and 6. But nobody is listening where the other one is speaking. Result: no communication. Nothing works. It's like two people talking at the same time, but neither one is listening. A crossover cable is wired differently. Instead of connecting pin 1 to pin 1, pin 2 to pin 2, etc., it crosses the wires for the transmit and receive pairs. Pin 1 on one side connects to pin 3 on the other. Pin 2 connects to pin 6, and vice versa. So now, when device A send on pins 1 and 2, device B receive it on pins 3 and 6. When device B send on pin 1 and 2, device A receives it on pins 3 and 6. Perfect communication. That's why it's called a crossover cable. The wire crossover inside the cable. What about newer devices? Nowadays, many modern devices like switches, routers, and NICs support a feature called Auto MDIX. This means the device can automatically detect whether it's connected to a similar device. It will switch its send and receive pins internally if needed. So, even if you use a regular straight-through cable, it will work like a crossover without you doing anything. Enter Auto MDIX, short for Automatic Medium Dependent Interface Crossover. Modern Ethernet ports can detect if they're plugged into a similar device and automatically swap the transmit and receive pins if needed. So whether you're using a straight-through or crossover cable, it just works. AutoMDIX makes setups faster, easier, and less prone to error, and it's support on almost all switches and computers from the last decade. While copper uses electricity to transmit data, fiber optic cables use light. Literally become of light short down a stand of glass or plastic. That light travels in a straight line or bunch of the wall of the fiber, moving data at incredible high speeds. Fiber has three major advantages. 1. Speed, 100 gigabits per second or more. 2. Distance, up to 40 kilometers and beyond. 3. Interference immunity. It's not affected by electromagnetic noise. Fiber is used in internet backbones, data centers, high-speed connections, high-speed building links. There are two main types of fiber: single-mode fiber, SMF, multimode fiber, MMF. Single-mode fiber, SMF, very thin core, approximately 9 microns, use lasers, travels very far, tens of kilometers, ideal for long-distance, high-speed networks. Multimode fiber, MMF, thicker core, 50, 62.5 microns. Use LEDs, cheaper but only good for short distance, under 550 meters, often used in campus or data center environments. The name says it all. Single mode, one path of light. Multimode, multimode path, which can cause signal distortion over long distance. So, which should you use? Use copper UTP for home and office networking. Affordable, and flexible setup. Use fiber for data centers, long distance or high-speed connections, environments with lots of interference. Let's go over the key Ethernet standards for fiber optic cables. This defines the speed, the type of fiber, and the maximum distance. Now, you understand how Ethernet cabling really works. This knowledge is essential for building modern networks. Like if this helped you out. Subscribe for more no-nonsense tech breakdowns. And as always, stay connected.